Okay, welcome to Cornell Notes Unit 9 with Ms. Ungerleider. Our topic today is going to be ecosystems. So please put your first and last name on your Cornell Note sheet, put today's date, and put the topic. Obviously, today's subject is science. So please go ahead and fill out the top portion of your Cornell Notes sheet. Because today, we're going to be talking about ecosystems. Okay, so before we start talking about the intricacies of ecosystems, we need to figure out, or we need to know what ecology means. Okay, O-L-O-G-Y means the study of something, and E-C-O, what do you think that means? Nature, ecosystems, that's right. Okay, very good. So the study of the interactions that the study of the interactions that take place among organisms and their environment, that is ecology. So essentially, we're going to be studying living things and how they interact with other living things or non-living things within their environment. You will have a vocabulary test for this unit, and you will have a unit test for this unit. It is my personal opinion that this unit test is probably one of the easier ones. Obviously not as easy as safety. That was stupid easy, right? But it's definitely one of the easier ones. And I think it's just more relatable. It's not abstract like chemistry. So hopefully you'll really enjoy it. We'll be doing quite a few labs. Okay, let's start off with what an ecosystem is. So go ahead and put the word ecosystem to the left. So an ecosystem is all of the organisms that are living in an area and the non-living features of the environment. So you've got both living and non-living pieces of the ecosystem. So all the organisms living in an area and the non-living features of their environment. Okay, so our next slide. Let's talk about some factors that you will find in an ecosystem. So there's this word called abiotic. Okay, and what it means is essentially non-living, never living. Okay, so let's break that word down. Anytime you put that in front of a word, it means not. And then bio means living. So abio or abiotic means not living, never living. Okay, some examples of abiotic factors that you will find in ecosystems will be water, air, rock. If you're talking about the ecosystem's temperature, that would be an abiotic factor. Sunlight would be an abiotic factor. One that is not listed here would be like rainfall. That would be an abiotic factor. Notice that water, air, rocks, temperature, sunlight, all those things are not living. They were never living. They are not made of things that were once living. Does that make sense? I'm going to say that again. They're not made of things that were once living. Okay, H2O is not living. It's just H2O. Okay? What is H2O again? Very good. Okay, so moving along. The opposite of abiotic is biotic. So literally, biotic means living or once living. Okay, so this is where you've got your living organisms or things that were once living or things that are made of living things. So your plants, your animals, your little single-celled organisms that you cannot see with your eyes. You would have to look at them under a microscope. Fungi, the list for the list for biotic can go on and on and on. Because in an ecosystem, there are thousands of living things, or things that were made of living things. So think about soil, okay, and think about whether or not you would classify soil as being biotic or abiotic, and why. So I'm going to give you some think time. Okay, so let's talk about the organization of an ecosystem. You don't have to write this whole paragraph, okay? Let's just go ahead and write the underlined parts because the underlined parts are actually going to be discussed in separate slides coming up. So the biotic or living components of an ecosystem can be divided into subgroups. So an organism is the smallest grouping. A group of the same organism in the same area is called a population. All the populations in an area are called a community. And the communities and those abiotic or non-living, never living factors, those are what make up the ecosystem. Okay? So I'm going to go ahead and move forward, and we will separate this into those subgroups, and we'll talk about each of the subgroups. Okay? Okay, let's start with an organism. You've got one little hedgehog. So an organism is any living thing, any one living thing, okay? We are all organisms, right? Independently, separately. Now let's look at the next one, next subgroup. All the organisms in an ecosystem that belong to the same species would be a population. So we could essentially say that we are a population of Homo sapiens. Okay, each one of you individually is an organism, but all the organisms that exist within Ms. Ungerleider's ecosystem, okay, we've got a population of 8th grade students. Okay, you all belong to the same species. So are you seeing like how organism is like one, population is like more than one? Yeah? Okay, can I move forward? Okay, next, let's discuss a community. So all the populations of different species that live in an ecosystem. So when you're looking at that ecosystem and you see your population of, what did we say those were, hedgehogs? What are they? Gophers. I like that. Let's go with that. Prairie dogs. Okay. So all the populations of the different species. So here you've got your prairie dogs. Here you've got your quails. Here you've got your badgers. Okay. So all the populations of different species that live in an ecosystem, that is what we call a community. And then finally, you've got an ecosystem. And that is all the living organisms that live in the area and the non-living features of their environment. Okay, so we just discussed organisms, populations, communities, and ecosystems, and how they are organized within the different ecosystems. Can I move forward? Those of you who have handouts, look at them. Okay, we're going to skip this part, and if we have time, we'll come back to it. Okay, let's go ahead and talk about symbiosis. Actually, you know what? I want to go to this. No, I don't. Okay, change my mind. Raise your hand if you've heard this word before. Symbiosis. Okay, very good. So, symbiosis is defined as an interaction that takes place between two different organisms that are living in close proximity. Say that again. Symbiosis is defined as interactions that take place between two different organisms living in close proximity. And sometimes they are beneficial, sometimes they are harmful, and sometimes one benefits and the other one isn't harmed. So let's look at, or we're going to study some examples of symbiosis. Please write down mutualism, commensalism, and parasitism. Okay, so if you look at your examples of symbiosis, you'll notice mutualism, commensalism, and parasitism. Okay, and just by looking at those words, you may be able to figure out kind of what they mean. Okay, so let's look at the word mutualism. What does that word sound like? What does that word include? The word mutual. Okay, so what can you infer about mutualism? Think about it. Huh? Okay, that both of them maybe benefit mutually. Okay, commensalism. That one's a little bit more of a tricky word, but look at the last one, parasitism. When you hear me say parasitism, what does that sound like? Parasite. So you might be able to infer that parasitism will be the one where one benefits and the other is harmed. Okay, we'll see. Let's look. Okay, so let's look at mutualism. You do not have to write this whole thing. It is my expectation that you're pulling out the important parts. And I didn't underline them for you this time. So see if you can figure them out. Okay, so we're discussing interactions between species. We know this is called symbiosis. So let's look at mutualism. Okay, so mutualism is an interaction between two species and where both benefit. Okay, so let's go ahead and use those as keywords. Okay, mutualism are when these species are interacting with each other and both of them are benefiting. Remember that this involves them living closely together in symbiosis. So mutualism is a type of symbiosis. You might want to write down the examples, hint, hint. Remember, I tend to use these examples quite a bit on my unit test. So the chances of mutualism on your unit test being described as this is very high. Look, the example says flowers and bees. They get the nectar, so the bees get the nectar they need to make honey, and they take the pollen from one plant to another. So that essentially pollinates the flowers, and both species benefit, right? So the bees are getting what they need to make honey, the flowers are getting pollinated, and the flowers are then able to reproduce, right? So that is an example of mutualism. Does anyone have any questions about mutualism? We're going to do a symbiosis activity probably tomorrow. Okay? Okay, so let's talk about commensalism. It's an association between two organisms where one benefits and the other one does not benefit, nor is it harmed. Okay, does that make sense? So one species will benefit and the other species does not receive any benefit nor harm. So one is benefiting, the other one is unaffected, essentially. That's commensalism. So an example of commensalism would be a sea anemone providing protection for a clownfish. The sea anemone does not really receive a benefit. But that clownfish sure does. Do you guys remember from Finding Nemo? A lot of animals, one of the reasons why clownfish will hide inside the sea anemone is because it provides protection. Sea anemones, they are provide this kind of shock to the other creatures around it, and so, but the clownfish is not shocked by it. So it provides this protection. Okay, can I move forward? Commensalism, do we have any questions about commensalism? Okay, let's talk about parasitism. Okay, and for those of you who are hearing the word parasite, in the word parasitism, you're headed in the right direction. So a parasitism is a relationship between two living organisms where one of them, the parasite, benefits or lives off of the other, and the other organism is what? Harmed. And it doesn't say that there, does it? Probably need to include that. Parasitism is a relationship between two things in which one of them, the parasite, benefits or lives off the other one, and the other animal is harmed. So an example of parasitism would be fleas on a dog. For those of you who have pets, you know that the fleas, they are a parasite. They feed or they live off the dog, and obviously the dog is harmed. This is another type of interaction of species. Predation. What does predation sound like? Predator. Okay, so predation is just a word that means the preying of one animal on another. So the type of activity that the flea has on the dog could be considered predation. Okay. I am really hoping that you guys already know this. I am really praying that this slide is just a review. Okay? So if you need to write this information down because you don't know it or you need to study it, that's fine with me. If you don't need to write it down, that's fine too. Okay, so obviously producers are living things that create their own energy through photosynthesis. Okay, so like plants, they produce their own energy. Okay, consumers, they consume that energy from the producers or other animals. Okay, so consumers, they can eat the producers or they can eat other consumers, depending on whether they are meat eaters or plant eaters, right? Okay, decomposers, they break down energy into nutrients. Okay, so some examples of decomposers are going to be your bacterias, your mold, your fungi. Some insects will help decompose. How are we feeling about this slide? Thumbs up, thumbs to the middle, thumbs down. Good. Okay, you are going to have a food web on your unit test. And every year I get this big question. Ms. Ungerleider, what is the difference between a food web and a food chain? Can y'all see it by just looking? Are y'all noticing that a food web is made up of several food chains? Okay, so a food web is representative of feeding relationships within an ecosystem. Okay, so if you look at that food web, you'll see all the little animals that are in that ecosystem. And depending on the ecosystem, the food web would be different, right? Okay, now this is a really key idea here. I need you to circle this, write this, underline this, highlight this, but you need to know this. And this will help you even in college and high school. See those arrows in the food web? They point from the consumed to the consumer. And think about what that means. Those arrows in those food webs, they point from the consumed to the consumer. So it shows you essentially the direction of energy transfer. So think about that. The grasshoppers and the sparrow, the arrow is pointing from the consumed, the grasshopper, to the consumer, to the sparrows. So the arrow is pointing in the direction that the energy is being transferred. Does that make sense? Okay, because the sparrow gets its energy from eating that grasshopper. And another thing you'll notice about these food webs is that the producers will all be at the bottom and the consumers will be at the top. Okay, and the primary consumers will be at the very top. So they would be like at the top of the food chain within that ecosystem. So let's look at this food web. Okay, and I want you to identify the producers. So remember we said the producers are at the bottom. Show me with your fingers how many producers there are in this food web. Okay, if you are thinking 3 or saying 3 or holding up 3 fingers, you are correct. Okay, so this is my question to you. Who preys on the grasshoppers? I already said it. The sparrows. Okay, who else preys on the grasshoppers? Emily? You are correct. The mice and the hawks. Okay. Let's talk about fires really quick. Okay, fires aren't always so bad in an ecosystem. Okay, and do y'all know which state is really dealing with this quite a bit right now? Yes, California, that's right. Okay, obviously people lose their homes and that's terrible. Okay, but there are actually some benefits to fires within an ecosystem. So let's go ahead and write these because you will be tested over them. The benefits of a fire is that the soil becomes more fertile. Okay, so everything that is dead or not really serving its purpose anymore, kind of broken or run down, is destroyed. It's burned by the fire. But essentially what fire does is it puts all these nutrients back inside the soil. Okay, so the soil becomes much, much more fertile. Also, it promotes diversity and new plant growth. Okay, it gives new species, more diverse species, the opportunity to grow and flourish. So those are some benefits. Obviously, some disadvantages would be the loss of property or soil damage, because fires, they can damage the soil, but then again, they can also make the soil more fertile. Let's go ahead and look at this fire cycle. Okay, so a fire starts by either lightning or by man. And I'm over here where you see the firefighter. Okay, the new growth produces a variety of food. And then as the forest grows, it provides home and food for changing kinds of wildlife. Okay, as the forest gets older, food for the wildlife is then reduced. Okay, and then one of two things can happen. Okay, there can be a fire and the entire cycle starts over again, or there is no fire and this is what happens. So dense trees, they stand and they rob those lower plants of sunlight. Many will die and pile up as dead wood and litter. Okay, and then essentially once there is a fire, the fires will burn hotter and they're more dangerous. So a lot of times they will do what's called a controlled burn. Okay, when they notice that there's an old forest, you know, and there's this lack of diversity and there's not really enough food anymore. Okay, you've got all these dead and piled up and littered trees everywhere. A lot of times the Forest Service will go ahead and burn. Okay, and it's called a controlled burn. They'll do it on purpose to start this fire cycle. Okay, let's watch this video over the Yosemite sequoias.
This fire in Yosemite National Park will consume 70 acres of forest, as big as 68 football fields. And it was deliberately started by man. For most of the last century, naturally occurring fires in Yosemite, usually caused by lightning, were put out whenever they started. The result was an incredible buildup of deadwood and undergrowth, which fueled catastrophic infernos. Now, National Park firefighters play catch-up. They manage and allow naturally occurring fires to burn, or set controlled fires like this.
We can't let all fires burn, and we can't put all fires out. We have to find that medium, but understand that fire is a vital and important part of our ecosystem.
This fire has special significance and special risks because it is burning in one of the most historically important few square miles of all Yosemite. The Mariposa Grove of giant sequoias, Yosemite's largest remaining stand of these great trees. The sequoias are an iconic symbol of Yosemite. This grove was one of the main reasons President Lincoln took time out from the Civil War to declare Yosemite a protected place in 1864. When it was policy to stop fires at all costs, few sequoias sprouted. Why was an enduring mystery finally solved just a few decades ago. Giant sequoias depend on fire to reproduce. The heat opens their seed cones. Their seeds are released. The flames clear the earth for their germination. While lesser trees blaze around them, the giant sequoias stand virtually unscathed by the flames. They're remarkably fire-resistant. Their bark is possibly the thickest of any known tree on Earth, sometimes more than 2 feet at the base of the tree. It prevents flames of fast-burning fires from reaching the interior of the tree.
They have seen fire for eons, and they will continue to see it if we have anything to do about it.
When the flames die down, the Earth is ready for a new generation of giant sequoias. They're one of the oldest living things on Earth. Some have been around some 3,000 years, and they stand as tall as a 27-story building, one of the natural symbols that make Yosemite National Park one of America's greatest wonders.
Located in the granite.
Okay, and that's it. Thank you for taking Cornell Notes with Miss Ungerleider.